Okay, so welcome back, year 11s. What I'm going to do in this next video is I'm going to go through the next section in your Learning from Home booklet. This is going through a particular type of group of functions called polynomials. Now, in the book, there's a bit of an explanation of what these are. Basically, I'm just going to go through the main things that you need to kind of know here. So here, polynomials, they're a group of functions where they follow this particular form that I have written down, and I'm going to highlight in this blue box. So it's a group of functions where you have multiples of positive powers of x or constant. So here, multiples of positive powers of x. So what you notice is that if you have a look at all the terms here, I've got xn, xn minus 1, xn minus 2, x squared, x, and a constant term which doesn't have an x term in it. All of these powers, so n, n minus 1, n minus 2, 2, 1, these are all positive integer powers. I forgot to put that in. It's meant to be integer powers as well. What it means is that they are positive whole numbers. So you can't have fractions. You can't have negative numbers in these powers of x. The second part is multiples. Now, if you have a look in front of all of them, we've got these an, an minus 1, an minus 2, a2, a1, and a0. These are all just these are the coefficients. Now, these an, you don't need to worry too much about what the n's are. They just use it as notation for just corresponding to the relevant powers of x. So here, the multiples is just the coefficients that we have in front of them. Now what I'm going to do is I'm going to break down a few of the key terms that you need to know with polynomials. Now the first one is the degree of a polynomial. Degree of a polynomial. And so what mathematicians often write is that they often write this as deg and then p of x. So this is notation. DEG, short for degree of a polynomial. So the degree is just the highest power of x. So for example, in the example up above, what we're looking for is the highest power, so highest little thing above x in my expression here, in my polynomial here. If you have a look, this n term, so n is the highest power of x in this expression here, because every term below it is just smaller than n. Yes, that is here. So here n. Another thing to notice is that often when we write polynomials, we'll write them in order of the of the power. So you start with the highest power and then you work your way down. So you have a look, we have n, then the next number that's below n is n minus 1, then we have n minus 2, and then so on until we get to a term that doesn't have an x power of x here. Okay, so the degree is just the highest power of x. The next thing is then the leading term. The leading term is the term with that highest power of x. So the term with the highest power of x. So e.g., for our expression above, the leading term is this whole first term here. This whole first term. So e.g., the leading term is an, which is the coefficient of the x to the power n, x to the power n. The leading term is just the whole term which has the highest power of x. So that's what the leading term is. The next bit of terminology you need to know is what a leading coefficient is. Leading coefficient is the coefficient of the leading term. So what I said was the coefficients are just those a values here. So an is our leading coefficient. So e.g. an for this one here. And the last piece of terminology that you need to know is what a constant term is. A constant term. The constant term is the term without a pronumeral. So for example, if you have a look at all the things here, Oh, without a variable, I should say a variable, because it's very different to a polynomial here. A variable. If you have a look at my polynomial up here, all of my terms here have an x in it, with exception of one term. The term at the very end, a0, is the constant term. So e.g. a0, just a constant term at the end, which doesn't have a power of x. So those are the 4 key terms that you need to be able to identify with your polynomial. Now, we've actually dealt with a few polynomials before. So for example, linear functions are a polynomial, because linear functions, p of x is equal to 4x plus 2, for example. Linear functions have degree 1, so if you have a look, this x term, it has a power 1 that's hidden there. So the degree of linear functions is, so degree of our polynomial here is equal to 1. It has positive powers of x, so here we only have that first term. We have the highest power of x is 1. The leading term is just 4x, and we've got a leading coefficient of 4, and the constant term is 2. We've also looked at quadratic functions. And so with our quadratic functions, we've got p of x is equal to x, or something like 2x squared plus 3x plus 1. That's also an example of a polynomial as well.